Few? Oh, awesome. Fantastic. My friend Carl Franklin started .NET Rocks back in 2002. It's a free-to-download show. We put one out every week. Tomorrow we'll publish episode 1625. Or actually, that was today. We'll publish it today. And then I also make a show for IT pros called Run As Radio since 2007. So that's once a week, every Wednesday. And for a brief interval, we made a show called The Tablet Show for 3 years or so, and then we stopped. Part of .NET Rocks, we do these Geek Out episodes. So this is whatever geeky subject the listeners want. And I did do a show about building bases on the moon, because I thought it was cool and people wanted to talk about it. And then that was in March of 2017, we published that show. And in summer of 2017, NASA called, which is a great day when NASA calls. You should answer the phone that day. That's always a good day. And asked me if I would do a version of the podcast as a talk at NASA. They asked me if I knew about PowerPoint. I said, yeah, I could probably figure out PowerPoint. Anyway, I got a chance to go to NASA and present their own stuff back to them. And so this is a version of that particular presentation, trying to talk coherently about what it would really mean to build a base on the moon and whether this is a real thing or not. And there's lots of folks, I mean, space is at a high right now. We've been very excited. Elon Musk has been doing his thing with SpaceX and is flying missions on a routine basis. Not as well known, but I think equally as important is Jeff Bezos and his company Blue Origin. And although his particular focus is actually on we're putting manufacturing into space. So Elon's focus is on getting humans to Mars, which sounds like a science fiction movie, and for the most part it is. Jeff's is a little more down to earth. He wants to start moving manufacturing into space and reduce the ecological impact on the planet. Does it make sense? Well, we can explore this thing. The moon is far away. It's a complicated place to get to. And this is one of my favorite pictures in the world. It's real. And if you're a science thinker, the thing you should look at when you look at this photo is say, who took this picture? Because we're looking at the far side of the moon here, right? Like, that's a pretty tricky angle to get. This is not a normal selfie. So this picture was taken by the Deep Space Climate Observatory. And it's actually a solar radiation and weather satellite. So it's mostly looking at the sun. But in order to look at the sun, it sits in an orbit called an L1 orbit, which is on the far side of the moon, balanced between the Earth-Moon system and the sun. And it's watching behavior of the sun and transmitting that information back to Earth. We have solar weather. And somebody was smart enough to put a camera on the other side of that satellite, so because it's always looking at the Earth, and because of its position relative to the sun, it always sees a full sphere of the Earth. So it takes very good pictures of the Earth. And once in a while, the moon buzzes across the frame. And so this is one of those occasions where the moon came whizzing across the frame. Now, if you really stare at this picture, you'll notice that the right side edge of the moon has a little green haze on it. I don't know if you can see that, but there's a reason for that. It's one of the reasons people think this image might be faked, is why has it got that fuzz on it? And I would argue that that fuzz on it is proof that it's real, because Photoshop people don't add fuzz, they remove fuzz. But the reason is simple. The sensor on that satellite only takes one color picture at a time. It's not a multicolor CCD. And so they actually put different filters in front of it to assemble a color photo. Now, when you're photographing the Earth, which doesn't move very much, doesn't have any problems with that. But when you're photographing the moon, which is actually moving quite rapidly across this frame, and you need to take 4 photos with a 36-second exposure each, you end up with some blur. So it's a natural artifact of the way they take that picture. And it's part of what makes it so interesting. Of course, the far side of the moon is not dark, irrespective of what Pink Floyd thinks. Right? It gets just as much light as the near side of the moon, but the moon is tidally locked to the Earth, and it doesn't rotate relative to the Earth. And that's part of this whole battle we have with great science fiction movies that make us believe we can do anything versus the science fact of what's actually hard and what's possible. Going to the moon has been going on for quite some time. Recently, Google had an Xprize, which this ended last year, where they were offering $30 million to anyone that could land a device on the moon that would then move around the moon and send back video. Nobody collected on this prize. They ended it in March of 2018, although we are starting to see some hardware now. these Xprizes are fairly common things. I mean, going all the way back to Charles Lindbergh crossing the Atlantic was a kind of Xprize. The last Xprize collected was with Spaceship One in 2004, a commercially made vehicle that could fly above the Kármán line. But if you really want to talk about the moon, we should talk about Apollo. So this year represents 50 years. It was 1969 when humans first landed on the moon in the Apollo project. But I think the important thing to realize about the Apollo project is that this was a military initiative by the United States to compete with the Soviet Union. So the Soviets have been leading in space, starting with Sputnik and then putting Yuri Gagarin into orbit. And so the Americans picked a goal far enough away, far enough advanced, that they thought they could actually catch up and exceed them. And it affected the Soviet psyche in a non-trivial way. I mean, the Americans are nuts. They did it. They put humans on the moon with fairly fragile bits of equipment. So President John F. Kennedy made his announcement at Rice University in 1962 that they would put men on the moon, and 7 years later, the Americans pulled it off. They only had a few missions that actually went to the moon, and this is a picture of Gene Cernan, the last man on the moon, in 1972. He did 3 surface EVAs of 7 hours each over a period of 3 days, collected about 250 pounds of rock, or 100 kilos of rock, to take back. And he ended these last missions by saying that America's challenge today has forged man's destiny of tomorrow. Now, I have nothing bad to say about Gene Cernan, fascinating man, naval aviator. In fact, all of the people that went to the moon were military, with the exception of one, this one. This is Jack Schmitt, or Harrison Schmitt is the actual name. He was originally going to fly on Apollo 18, and that mission got canceled. But he was a geologist, where every other Apollo astronaut was a pilot. This was a geologist. Now, he had worked with those astronauts to teach them enough geology to collect important rocks on the moon. And yet, when he went to the moon, he found dramatically more important geological evidence than all of the other astronauts together. Because in the end, science is actually about finding the exception. It's never eureka, it's always, well, that's weird. And that's what he found. His eyes, his experienced ability to see unusual geological formations, turned up very unusual rocks. This is troglodyte 76535, but we'll call him Dave. So this is a rock named Dave, and it is easily the most important rock that all of the Apollo astronauts found. And why is it important? Well, for starters, it's extremely old. It's 4.3 billion years old, where the Earth itself is only 4.5 billion years old. And it is an unshocked olivine rock. So what does that mean? Well, we were trying to understand how the moon was even formed. And part of the Apollo science missions was, could we get a better understanding of where the moon actually came from? And one of the working theories was called the Fea Theory. And that is the theory that during the early first 100, 200 million years of the formation of the solar system, a proto-Earth was collided with a fairly substantial body we named Thea. And in that collision, it actually blew a lot of surface material off of the Earth and reformed as an unusually large moon that initially orbited very close to the Earth and is slowly spinning away, which is what the moon is still doing today. And one of the ways they could prove that is that they could show that it actually formed and had volcanic activity that looks to be condensing, and that its oldest rocks would be younger than the oldest rocks on the moon. And that is exactly what this rock is. This rock was not created by impact. It was created by volcanic activity on the moon. And the fact that there was volcanic activity on the moon speaks to a lot of the formation of the moon and also our opportunities up there. Now, Apollo can't do everything, right? If you actually look at a map of all of the places that the Apollo missions landed, it's a fairly narrow area on the moon. That was the limitations of the technology at the time. It was the 1960s, it was a race, it was a rush job, the Apollo missions. And so the furthest distance between these two, between Apollo 12 and Apollo 17, is about 1,800 kilometers. Roughly the short way across the Sahara Desert. So you can imagine if you were sending probes down to understand the Earth, and you landed every one of your probes in the Sahara Desert, you would have a very limited view of what the Earth actually is like. And that's one of the problems we have with Apollo, is that they landed relatively close to the equator on the near side of the moon because of limitations of technology, and they only saw a limited number of things. And they also only ran for a brief amount of time. This was just a few years with fairly limited technology. Their spacecraft was remarkably fragile, and it had a number of unrecoverable failure nodes, which is to say, if anything had gone wrong with this lander at all, those guys were dead. It was a minimum of 3 days to launch a rescue mission, and they only had about 3 days worth of air. So if the lunar lander had tipped over, if an engine had misfired, if anything had gone wrong, there was no way for them to survive. And when you realize that the Americans were motivated to show their superiority over the Soviet Union, continuing these missions made no sense for them. The risk was too great. And so they ended it pretty much as quickly as they could and moved on to the space shuttle. And it's not that the Soviets weren't trying to match them. The Soviets also had a moon rocket. We didn't hear much about it until after the Cold War was over in the 1990s. This was the Enron Rocket. And in many ways, it was comparable to the Saturn V rocket. They did attempt to fly 4 versions of this rocket, all of which ended in a spectacular firework. The most spectacular one lifted only a few feet off the ground and then exploded violently, not only destroying the rocket, but the entire pad. And it took a year to rebuild from it. Of course, at that time, the Soviet Union was incredibly secretive, and so they never admitted that any of these things happened, although U.S. spy agencies knew because they had pictures of the big blast hole where the rocket used to be. The Soviet system was smaller. It could have worked if they'd continued spending on it. By 1972, when the Americans were wrapping up going to the moon, they decided to shut down this rocket, and they've not continued to fly it. Although I would say there's a lot of technology that comes from the N1 rocket that you can still see today. The AJ-6 engine that the Americans still buy from the Russians is derived from the engines on the N1. Now, most folks think that that's the end of the moon. By the end of the Apollo missions, nothing more happens with the moon. And it's true that for about 20 years, nobody did anything with the moon for the most part. The restart of moon exploration with technology actually comes towards the end of the Cold War. So in about 1983, that's Ronald Reagan's government, they created a thing called the Strategic Defense Initiative, although all of us called it Star Wars, because it was the idea that we could use space-based equipment to shoot down nuclear missiles in flight. This was a map of the SDI initiative, all the different technologies. And I love that they had technology called Brilliant Pebbles. They were great at naming things, those Americans. And some of this hardware actually got built. The Soviets took the SDI initiative very seriously. And one of the reasons they took it so seriously is that the Americans had flown to the moon. It's like they say they're going to do crazy things, and then they do them. We better take this pretty seriously. And there's an argument this partly affected the collapse of the Soviet Union, that the spending on defense actually crippled that country to the point where the Soviet Union broke up and became the Russian Federation. SDI did not come to fruition. They never did launch an umbrella of systems to shoot down missiles in flight. The Americans continued to work on variations of this idea, but this particular approach was shelved. However, some hardware was built. And in the late 80s, they decided to reuse that hardware. So the Ballistic Missile Defense Organization went to NASA and said, hey, we have one of these Brilliant Pebbles. We built the prototype of it. Would you like to use it as a space probe? And NASA said, sure. Now, this is not that unusual thing. The Hubble Space Telescope is actually the chassis of an NSA spy satellite. They just turned it into a telescope. And so same thing here. The BDMO offered up a platform for NASA to fly a mission, which they ultimately decided to fly to the moon and to an asteroid. Now, they named the mission Clementine. And the reason they named it was for the song, where Clementine is lost and gone forever. Well, this was a spacecraft that was going to fly around the moon a few times and then fly off to an asteroid, and then it would be lost and gone forever, because rocket scientists are just a little bit silly. Now, I bring up Clementine because it was the first time they flew something to the moon since Apollo. So in 1994, this spacecraft took off from the Vandenberg Air Force Base in California, flew out to the moon, and it spent 2 months mapping the moon. We'd never gotten really detailed maps of the moon, and Clementine wasn't the most amazing satellite. It was a prototype and an experiment, and ultimately it did provide some interesting maps, but it also did some bistatic radar experiments where it bounced radar signals off the poles of the moon. There had been a theory that had been floated around for some time that there might be ice on the poles of the moon in parts of continuously shadowed craters. And the bistatic experiments of Clementine showed unusual reflectivity on the poles. It was sort of the first indication there might be something there. And so shortly after that, they lost control of Clementine, and it really was lost and gone forever. But it wasn't the end of the missions. A few years later, they built another spacecraft called Lunar Prospector. And in '98, this flew from Cape Canaveral to the moon, where it orbited it for a number of years. And it did more detailed spectrographic mappings of the moon. It's the sensors that actually determine that there are radioactive compounds like uranium and thorium on the moon, along with potassium, rare earth materials. A lot of useful compounds, a lot of useful elements are scattered on the moon. The most important spacecraft still flying around the moon today is called the Lunar Reconnaissance Orbiter. So this was launched back in 2009. It was supposed to operate for a year, and at the 10-year mark, it's still running. And it's provided most of the very detailed maps that we now have of the moon. It has mapped almost every inch of the moon possible. And you may have seen some LRO photos, whether you realized it or not. They took the detailed pictures of the landing sites of Apollo. So you may have seen some of these images where they actually have an overhead view that shows the descent stage, the footprints. These are pictures from the Lunar Reconnaissance Orbiter. That's where they come from. Something I find very interesting is you notice how dark the footprints are against the undisturbed regolith of the moon. And this is science that's still ongoing, that the radiation from the sun is actually bleaching the surface of the moon. And as soon as you disturb it, the material underneath is much darker. These are all LRO images, and they're still making more as time goes by. And I mentioned that I did this presentation at NASA. One of the folks that I was presenting to was an engineer by the name of Dan Andrews, and he helped build that LRO mission. And he was also the principal on a secondary payload that was on the LRO flight called L-Cross. So they had a little bit of additional lift left over for the rocket that was going to fly the Lunar Reconnaissance Orbiter to the moon. And so they were trying to come up with a mission. What could we do? What could we add to increase the value of our exploration of the moon? And Dan Andrews and a group of scientists had an idea they really wanted to measure water. Let's get proof that there is water. And so the idea was to use the second stage booster, which is the Centaur booster, as an impactor. They were going to slam it in the moon at just the right angle that it would kick up a spray of debris, and then they'd have this sensor array behind it, only a few minutes, because it's going to hit the moon too, to take pictures of the spray. And if they could get a spectrographic analysis to see if there's actually water. So that meant precisely preparing that booster so that it would not contaminate the scene, and hitting a spot of continuously shaded crater dead on at a correct angle so that it would actually kick up enough debris that you could run a spectroscope through it for the minute or so that you had before your sensor also slammed into the moon. Does it seem insane? It worked. And so it took several months to prepare all the parts after it had gone up, but they actually sent that Centaur booster into the side of the Sabis crater and kicked up a huge spray of dust, and then the sensor array mapped it, and they found not just water, but an array of volatile compounds. Nitroxides, ammonia, hydroxides, and hydroxyls, which made no sense. We thought we understood the chemistry of the moon, that it was going to be a dry, barren place, that there might be ice crystals left over from cometary impacts that would be hard, but there would just be water. This array of compounds was kind of crazy, and it sort of broke the science model. It was like, okay, well, we don't understand what's going on the moon. Now, I had the good fortune, after making this presentation, if I sound like I'm sucking up a lot about the L-Cross mission, the dude was in the room, all right? And I actually at one point said, if it sounds like I'm sucking up a little bit about the L-Cross mission, it's because I know Dan Andrews is sitting right there. So Mr. Andrews gave me an hour of his time after the presentation and told me something that I had to go back and later read about, which is that the impactor landed late. So you imagine they had mapped with the Lunar Reconnaissance Orbiter the moon in great detail to figure out the perfect spot for this impactor. And they knew exactly how high it was, what the distance was for it to impact on. And they have seismometers already positioned on the moon from past missions, right, from the Apollo missions, that can measure moonquakes and report back to them. So they knew the exact moment that the impactor hit the moon, because it shook the moon enough that they could measure it. And the time that it should have impacted based on the radar telemetry and the time that it caused that seismic impact was several dozen milliseconds off. It doesn't sound like a lot, but let me tell you, that Centaur booster, which is the size of a bus, was moving. And so why was it late? And one of the theories is that there's a process going on the moon right now that is creating crystals all the time that are ionized, they're magnetic, and so the magnetic fields of the moon drag them around, and they ultimately break up in the heat of the sun, or they get pulled into these continuously shaded spots where they freeze in place, and they pile up like snowflakes. And radar can't go through that, so it bounced off and you thought it was solid surface, but it might have been meters and meters of fine, volatile dust, and that's what that Centaur booster impacted. It was important enough that there was a follow-up mission a few years later called LADEE. And LADEE was specifically interested in what they called the exosphere, which is another term for atmosphere, but when your atmosphere is so thin it's barely measurable, they call it an exosphere. So the LADEE mission actually explored the exosphere of the moon and helped support the idea that there's a constant chemical reaction going on between the sun and the moon. The sun emits a steady stream of protons from its fusion reaction, right? This is the solar radiation. And as it impacts the moon, it impacts with enough energy that every so often it grabs an oxygen molecule, or it grabs an aluminum molecule, or it grabs a silicon molecule. And these hydroxyls, these unstable combinations of hydrogen and another compound, they're energetic. And they're magnetically sensitive, and so they're the things that fly around and get frozen in different locations. So there might be a very slowly operating water production machine on the moon that's slamming together hydrogen and oxygen atoms on a regular basis and then freezing them in certain key locations. And that's what the LADEE mission revealed. Now there's a mission to follow up this that hasn't happened. It's called Resource Prospector. So this was Dan Andrews' next mission, and he has the prototypes of this built. It's a small rover that they would precisely land on the South Pole near a continuously shaded area, and then they would drive this little rover off and into the frozen spot, drill into the ground, extract a bit of that ice water, come back into the light, melt it down, and actually extract water from the moon. For a very low budget. Dan's amazing at building low-cost missions. The Trump administration has canceled this mission. Now, my gut instinct is, are you nuts? This sounds cool, but there's a bigger picture here, which is that actually the Trump administration is trying to put more money into moon research, and so low-cost missions were particularly appealing. What they've actually asked Ames, the facility that developed this mission with Dan Andrews, is to make those components available to the larger space community to build bigger missions around these same ideas. So while the Resource Prospector mission may be canceled in its current form, a lot of the technology they developed is going to be applied to doing additional exploration on the moon. Now, it's not just Americans that are exploring the moon. If you've been paying attention to the news, the Chinese recently landed the Chang'e 4 lander on the far side of the moon, the first time anyone has landed anything on the far side of the moon. And again, your scientific mind should be looking at this picture and going, who took this picture? Because it looks like a lander sitting on the moon. Maybe it's something that Stanley Kubrick would cook up. But that picture was actually taken from the rover They have a little rover called the Yuki 2 that drove away and then took a picture of its lander, and vice versa. Here's a lander taking a picture of the rover. Now, to be able to communicate with this device on the far side of the moon, they have actually flown another satellite. This is the relay satellite that sits in an orbit on the far side of the moon to relay signals from the lander and the rover back to the Earth. So this is a complex mission the Chinese have pulled off. And the Lunar Reconnaissance Orbiter has now imaged both the lander and the rover on the surface of the moon. So we're all kind of confirming each other's data. And if you were following the news on this, they had a little greenhouse on the Chang'e lander, and they actually sprouted some cottonwood seeds, who then shortly after that froze because their heaters aren't quite strong enough. One of the other pieces of science they've discovered is that it's colder on the far side of the moon than it is on the near side of the moon. It was unexpectedly cold there, and it's part of what ended what was supposed to be a 100-day experiment in greenhouse growing, only lasted a few days. That's what science looks like. You know, we've learned a little bit more there. And also, very recently, just a few weeks ago, a small lander built by an Israeli company was launched as a secondary payload on a SpaceX Falcon 9. And this vehicle is now on its way to the moon. It'll take a couple of months to get there. It's expected to land sometime in April. It is a fairly unsophisticated lander. They don't expect it to last more than a few days. It doesn't have a lot of thermal management. This was actually a Google Xprize project. Their goal was to win that Google Xprize that ended last year. And they, of course, even with the mission expired, they decided to still go ahead with it. It was largely funded by billionaires. Guys like Adelson and Bezos have contributed money to this project. They spent about $100 million, which for flying stuff to the moon is pretty cheap. But it'll be a short-lived lander if it makes it there. There's still a bunch of steps to actually succeed in this. But it'll be the first sort of privately funded lander on the moon ever. So I hope I've got you excited that there's a lot of activity going on the moon right now. There's a lot of experimentation going on. NASA's far from done. They've got a lot going on as well. In May of 2018, as a part of their commercial payload services, so they now buy supplies to the space station commercially, where they say, we're going to supply the supplies, we just want you to lift it there. They don't actually specify any more than that. It's like, this is how much we're going to need to move per year. You tell us what you can move. Well, they now put out a similar contract for payload supplies to the moon. At the same time, they are working on their own rocket that's being largely built by Lockheed Martin and Boeing. It's called the Space Launch System. It is derived from shuttle technology. So the real driver to a lot of respects is they have leftover parts from the shuttle mission, including 16 shuttle engines that they want to use up building enormous rockets with it. And they have a payload. This has been a rocket that they've tinkered with for literally decades, since even before the space shuttle missions ended in 2011. They were playing with trying to build a new rocket. The payload for this is a new space station. It's a space station called the Lunar Gateway. So it is a space station that is going to orbit the moon. Now, it's not going to be as big as ISS, but it doesn't need to be as big. But the idea is to station 3 to 4 people in an orbit around the moon for 6 months at a time and be able to do more research against the moon. The orbit is interesting. This is an animation of that particular orbit. The moon's gravity is somewhat unstable, and so it's very difficult to orbit close with large objects. And so this is an orbit that will actually fly very close to the moon on the North Pole and then a long way away on the South Pole. And so you're seeing that long reach down. Now, why is that important? Well, it's a stable orbit. It's called a near rectilinear orbit. But it also means that they have an extended view, about a week at a time, at the South Pole. And then briefly they fly across the North Pole, and then again spend most of their time in view of the South Pole, which is where most of the interest in new science and the moon is at. The moon's far enough away that it's very tough to teleoperate robots. But if you were in this space station, you'd be able to operate those robots quite easily from that particular orbit. So this orbit serves well for that kind of purpose. It's also a staging ground for a dedicated lander, that they want to develop landers that can go to and from the moon and be refueled and are fully reusable. And you need some place to fly to, and so the Gateway is a logical place to do that from. That's a bunch of NASA's current work, and the look at the next space station. Roscosmos is the Russian equivalent. The Russians are having economic challenges, as are many countries, but they have recently announced, recently being this past month, that they're going to develop a new rocket called the Yensei, named after a river. Now, it's going to be derived from a rocket called Energia. Towards the end of the Soviet Union, 1987 to 1988, the Energia rocket flew exactly twice, once with the Polonius payload and once with the Russian space shuttle called Buran. They only flew it once, and that was 1988. And in 1989, the Soviet Union collapsed. In fact, there was another entire Energia Buran stack assembled for flight that never flew. It sat in a storage facility until the roof of that facility collapsed on it. But this is an extraordinarily powerful rocket. So while many countries and many companies have proposed heavy lift rockets, the one group that I know for sure knows how to build them are the Russians. And so if they're going to take Energia and update it into a more powerful rocket, you kind of have to take that seriously. They do know what they're doing in that respect. And their goal is a series of missions to the moon, culminating in manned landings. So these are the missions they've outlined so far. Now, again, lots of places talk about missions. The question is, which ones do you take seriously? So the Luna 25 mission, and it's called that because landers on the moon for Russia have always been called Luna. The previous one, Luna 24, landed in 1974. So it's been a little while. But they have the hardware for Luna 25 already built. So this is a mission that's supposed to fly in the next year on the back of a Soyuz to do additional research on the surface of the moon. Then they're going to put up an orbiter that's very similar to the Lunar Reconnaissance orbiter. And then these two in the front here, 27 and 28, these are a bit more speculative missions, doing resource extraction and actually a sample return mission. So extracting some icy material from the moon and then flying it back to the Earth, which sounds far-fetched, but be aware, the Soviet Union did sample return missions from the moon in the 60s and 70s. So not unprecedented. But this is the Russians position themselves to also be participating in the moon. And in Europe, we have the ESA, the European Space Agency, and an International Space Exploration Coordination Group, which has been helping to make plans for bringing materials to the moon for a variety of different missions. This is using both American technology and Russian technology and European technology with the intent to maintain a base on the south pole of the moon, very much like Antarctica. 6 months at a time, groups of 4. They're actually talking about initially 42-day missions, so the day-night cycle on the moon is 14 days of light, 14 days of darkness. And so the proposal is that you would do a 14-day shift of light, a 14-day shift of night, a 14-day shift of light, and then you fly back. Now, the design of this comes from the Europeans, and it is inflatable space modules that are then buried in regolith to manage radiation. Again, all of this technology is fairly well-known science. We can actually construct this. You'd use robotic machines to actually do the digging and the burying. And again, the gateway station would help with this. If the robots have problems, it's easier for someone who's only a few milliseconds away by light to be able to control it and deal with those particular problems. As we start to think in terms of what the supplies would look like and what you need to do there are derived spacecraft for flying supply missions to and from the moon. This comes from Lockheed Martin. It's called the Jupiter, and it's actually derived from space station technology. So it's basically a space station resupply module scaled up a little bit to be able to fly back and forth between the moon and the Earth to bring supplies to that space station. The Russians have an equivalent, and they are using a heat shield actually as a deceleration device, so that rather than have to use thrusters to slow down when they get to the Earth, they would skim the atmosphere and slow down that way and then go into orbit. Blue Origin also made a proposal to put landers on the moon, carrying 10,000-pound payloads, so fairly large loads, and that ties in with NASA's initiatives. They're looking specifically at the Shackleton crater, and this is a design of a Shackleton base. Now, why is the Shackleton crater interesting? It's almost directly over the South Pole, and so the inner parts of that crater are always shadowed, and they almost certainly have ice in them, but the outer rim of that crater is almost continuously lit. So if you need solar power, which you're probably going to need, they have spots there where round the whole year there's light. The LRO made this animation showing an entire year's worth of lighting over the Shackleton crater. Now, I hope your mind is going, how did they make this picture? Because spaceships don't actually hover. They literally would snap the photo at exactly the same location as the satellite went around over and over and over again to get a time lapse of what a year looks like in the Shackleton crater. And there are parts of that western edge of the rim that are always lit. So they could have solar panels up there and all year round be able to generate electricity. Now, building sufficiently large solar panels to do that is not easy to do. That's a lot of solar panel. There's also some interesting research going on into nuclear power in this form factor as well. This is recent research just in the past couple of years as well. This is a technology called the kilopower reactor using Stirling technology, or Krusty. I don't know that I like that name. It's about a 10 kilowatt, largely solid state reactor. So at the far end there, we have the reactor core, which is about the size of a roll of paper towel, uranium-235. Encased with reflectors, it generates a fair bit of heat. They have a sodium heat pipe system. So the radioactive material heats up sodium that then flows up to the Stirling engines, which then rotate and generate electricity. And like I said, about 10 kilowatts of power, also 40 kilowatts of heat. So that's why the big piece here is the cooling fins. There's a lot of excess heat, although you could tap that heat and use it for other things as well. So these are sealed solid-state reactors. They should run for about 10 years without any interference. You don't need to do anything. They'll simply generate heat continuously, and so electricity. And they don't need light, and they don't need dark. They just run all the time. This is not a paper design. This is actually the prototype running, and that's in 2017. So this is basically a finished piece of tech. They're just waiting for a job. And that requires the question, what's the job? What will we do on the moon? We're all excited about Mars. Mars is easy to be excited about, right? We've made good movies about Mars, although they are just movies. And I'm pretty sure we don't need to rescue Matt Damon anymore. But we don't understand a lot of the key problems to functioning on Mars. And Mars is several months away from space flight, by space flight. So it's a dangerous place to go because it's very hard to get back from. But most of the tech that we need to develop for Mars, we can also develop on the moon, which is only a few days away. And so the first thing is, can we start manufacturing things on another planetary body? So that means exploration, extraction, refining, mining, and ultimately manufacturing, right? So building a plant on the moon. What would it look like? And if this picture seems odd to you, it should. This is actually a gravel sorting factory that's been inlaid into a picture of the moon. Well, I think they did a pretty good job. There's a little power pole right here where you're like, what's that power pole doing exactly? But there's another one over there. But yeah, that could be a machine scraping up regolith and then sorting it into the different compounds. Right? You'll need a certain amount of electricity. You have enough gravity, you can do those things. One of the things that's interesting about the particular combination of compounds that we already know that's on the moon, things like silicon and titanium, magnesium, phosphorus, and aluminum, is that they're all the ingredients for making solar panels. And that presents an interesting idea that we could manufacture solar panels on the moon, but not just for moon use. We could manufacture them for Earth use as well. And if you look closely at this picture, way off by the Earth there's something that looks a little bit like a margarita glass. That's SPS alpha. So SPS alpha is the most advanced idea we have for space-based power. This is something that Jeff Bezos is particularly interested in. A non-trivial amount of the pollutants we put into our planet are caused by generating electricity, whether that's by coal or natural gas, nuclear power, pick your poison. Even manufacturing solar panels creates fairly significant toxic waste, even if the electrical generation from it is not particularly damaging. But what if we could put solar panels in space and beam the power to the surface of the Earth? Now, this is all known technology. We use microwaves to penetrate through the atmosphere. You would use about a 1 kilometer wide array beaming down. It would land in a 10 kilometer patch. And in that 10 kilometer range, the energy levels aren't high enough to fry birds in flight or anything fun like that. You'd probably put a fence around it because you don't really want to walk around in there. But you are talking about being able to beam a gigawatt of power back to the surface of the planet. We could build this today. There's nothing technologically needed to do that. This particular design is built in such a way that it's what they call gravity gradient, so it naturally points to a stable location on the Earth, and it doesn't need to point towards the sun. The reflectors are oriented so that as the sun passes around the Earth, the light is always reflected down to the concentrators and onto the solar panels. That's what's cool about this design. It's stable, and it always beams to the same location on the planet. The problem is lift. The amount of mass you need to lift to generate a gigawatt of power makes it prohibitively expensive, hundreds of billions of dollars. And it's because the gravity well of the Earth is so strong. You need about 12.5 kilometers per second of lift to get off the Earth, but you need 2 to get off the Moon. So what if we manufactured the majority of the components for this thing, the heavy ones, on the Moon, and just shot them back to geostationary orbit and reassembled them? That actually gets our price for building space-based power into the single-digit billion-dollar range. We need to build out the infrastructure on the Moon, and it has a variety of purposes, but if you can manufacture that way, you can start moving power generation off the planet. And once you have a system like this, you can use it for more things. It can actually be a source of power for space-based propulsion. You can shoot those microwaves at rectennas on spacecraft and use it as the energy source for the spacecraft rather than to carry that around, make your vehicles lighter. So we start to think in terms of building up infrastructure for space travel. Now, we've had humans off the surface of the planet for more than 20 years. There's been between 3 and 9 humans in orbit since the 80s. And for the most part, they've been in the International Space Station. The International Space Station is reaching end of life. Somewhere around 2025, we're going to have to talk seriously about what to do with the space station. The Russians are talking about taking a few of their components and building another station with it, but the core components of the station are beginning to wear out. Now, what has the station done for humanity? One of the most important pieces of science it's developed is that we really deeply understand the effects of free fall on the human body, which is to say we now know it's bad. So the normal stay on the space station is about 6 months. And in those 6 months, you will be exercising 2 to 2.5 hours every day to maintain a reasonable amount of health so that when you return to 1G gravity, you can get back to functioning, although it'll take you the better part of a year to recover from that. Now, most physical functions work fine in free fall. All of your peristaltic systems, your digestion, your blood system, your breathing, they work great. There's one system that seems to not work at all, and it's called the cerebral spinal fluid system. So your brain emits a particular fluid that your brain sits in and then flows down into your spine. And it cleans off debris from your brain and brings it down to the spine where it's distributed through your kidneys to get out of your system. But it has no peristaltic pumps. And so it relies on gravity and your own motion to move that fluid out of your head and into your spine. Now, bedridden patients down here on Earth are daily sat up and banged on the back specifically to help that peristaltic system work. If you lay on your back continuously, you will also have problems with your cerebral spinal fluid. Now, how does this manifest on the space station? Well, you'll see that virtually every astronaut, when they're in the station, their face swells up. In fact, there's so much fluid accumulating in their head, it presses against the backs of their eyes and it bends their eyes. So all of them have to wear glasses while they're on the station. And sometimes their eyes don't go back into shape. So it's a non-trivial problem. And one of the discussion points here is if we really were going to fly people to Mars, which is a 2 to 3 year mission, the majority of it in free fall, they're not going to be functional humans when they get there. It's too long. It's too hard to recover. And even folks that get back from the station and land on the Earth have healthy people there to help them for months. You take a 6-month trip to Mars and then land on Mars, there's nobody to help you. So we're pretty confident now that if we're going to build a vehicle that can fly between the planets, it needs to have artificial gravity of some kind. And the only way we know how to do it is to make a spinning donut. So this is Nautilus 10. This is the most advanced theoretical design of a vehicle that could make a trip to Mars. And a key part of this is that big donut, is the centrifuge in the center of it, which is where humans would spend the majority of their time. Sometimes they need to go into free fall, and most of the time they would be staying inside that rotating ring, which would give them enough gravity to keep them healthy. Now, there's a problem with transitioning between free fall and gravity, but artificial gravity also has other problems too. The size of the ring and the rate that it rotates matters a lot. Your height inside of a ring means that the gravity at the top of your head and the gravity of your feet are going to be different. And so there's a long discussion to be had about how much gravity do we need to keep humans healthy. We know that 1G works, but building a 1G ring is really hard. There were supposed to be centrifuge experiments on the space station, but they ended up being canceled because most of the experiments going on the space station are microgravity related, and the centrifuge would disturb them, just the vibrations of it. And you think about the challenge of building something that large and rotating, and how the transfer ring works between the rest of the spacecraft and that ring. This is hard technology to solve. And there's a graph that sort of breaks down how much gravity you need versus what will keep people healthy and how large that ring needs to be. So we're pretty sure we're not going to build a 100-meter diameter ring. That's a big ring. And we don't want to be rotating more than 3 or 4 or 5 RPM. Any faster than that, and you have other problems. And so you end up in this zone of how big can we make it, how fast do we need to rotate it. Now this graph shows up to 1/3 of a G, because they were talking about Mars-level gravity. The moon has 1/6 of a G. And so one of the things we could study if we had people on the moon is how well humans function in 1/6 of a G. And the only way to know for sure is to put them in 1/6 of a G for an extended period of time, like a year. We've done that on the space station, and we know the consequence of it. We could do the same thing on the moon. And should we show how much healthier folks are if they can keep functioning 1/6 of a G, it completely changes our spacecraft designs. The ring gets smaller, it rotates slower, it's simpler to build, it's less expensive. It solves a ton of problems. So that station then is also a lab for humans, to understand humans working in lighter gravity, alongside our ability to do manufacturing, our ability to do in situ resource generation. Can we extract water and ice from the planet, separate it for fuel, separate it for breathing air? Can we extract elemental compounds and actually do manufacturing? There are other structures on the moon that are interesting. This is the Marius Skylight. So this is an opening into a lava tube. The gravity on the moon is dramatically lower, but there was volcanic activity in the earlier stages of the existence of the moon. And so it created lava tubes much the same way they're created on the Earth. Highly molten lava flows rapidly under the surface, then eventually penetrates in an eruption. And then it cools in layers, and ultimately part of that will drain out, and you end up with a hard shell wall cylinder. Now on Earth, typically those tubes are only a few meters across, but in much lower gravity, they could easily be 50, 60 meters across. Huge. This skylight is 60 meters across and estimated to be more than 80 meters deep. So there's an opening into a lava tube not far from the South Pole. We could, rather than build structures on the surface of the moon and then bury them, insert an inflatable habitat into a tube like this, and we have a huge amount of space with micrometeoroid and radiation protection already installed. The Japanese have proposed a mission, actually they're now building it, it's supposed to fly in 2021, called SLIM, or the Smart Lander for Investigating the Moon. And it has a couple of missions. One is precise landing. The landing radius of Apollo missions was about 20 kilometers. It was not a very precise landing process at all. If they're actually going to explore the Marius Skylight, they have to get within about 100 meters of it, but not in it, because that would be bad. So close landing, and then also some kind of rover or something to take a look at what's actually in that skylight and what the structure looks like. There's also a distinct possibility there's ice formations inside the skylight. That if this electrochemical process that we're starting to understand from the moon is creating these crystals, they could easily fall into the skylight and pile up in there as well. So there might be in those tubes a whole bunch of water ice and other reactors. Another interesting mission that the Naval Academy has explored is building radio telescopes on the far side of the moon. So using the moon as a barrier to all the electromagnetic emissions that the Earth produces to put incredibly sensitive telescopes on the far side of the moon and do detailed measurements of the sky with those. What's cool about radio telescopes is they don't have to be rigid. So this is a proposed design using capon strips that are magnetic, rolled out by robots over kilometers to build a massive radio telescope on the far side of the moon. So some unique science that we could do from the perch of the moon. And we're far from done from a geological perspective. We could be digging some holes in the ground, and you never know what you're going to find in a hole in the ground on the moon. You get this reference? Yeah? I would argue the best science fiction movie ever made, also one of the very first. The first time artificial intelligence was used in a movie was 2001: A Space Odyssey. It's why we believe that AI will kill us, because the first one we ever met tried to kill and did kill pretty much everybody. But also what first introduced us to the idea that we could simply do work on the moon. Right? This was a construction site. It's really built the same way as any other construction site. It just happens to be excavated on the moon. We have never looked below the soil of the moon more than a few centimeters. We don't know what's under there. We don't know what we could extract. I'm pretty sure it won't be a monolith. Though I was recently reading that up until the last minute, it was going to be a pyramid. They came up with the square, like the rectangle at the last second. But it's not the only thing that's done down there. Human science, building power plants for the Earth, in situ resource utilization, but also exploration for humanity. And I'm in Portugal, so I'd be remiss not to mention Ferdinand Magellan, because his quote, "The sea is dangerous and its storms terrible, but these obstacles have never been sufficient reasons to remain ashore. Unlike the mediocre, intrepid spirits seek victory over those things that seem impossible. It is with an iron will that they embark on the most daring of endeavors to meet the shadowy future without fear and conquer the unknown." That from the man who led the first group that went all the way around the Earth, from here. It is in our best interest as a species to always have a small fraction of us right at the edge, exploring something new, inspiring more people than are actually there, and potentially expanding our civilization. You go to the moon because it's next. If we are to become a spacefaring species, we need to learn, and the moon is the playground to learn in. Sure, our first look at it made it pretty bare, but as the Ames guys were saying, only 3 days away, plenty of water, gravity, no weather. It's a good spot to work from. It has all of the ingredients to learn from. What you learn there, you then apply further afield. The alternative is to wither and die. Sure, there's problems here, and we're working on those problems. One would argue this is one of the best times in civilization ever. Your lifespans are longer. Your children are more likely to survive. Do we have problems? Yeah, we have problems. But that doesn't mean we should stop exploring. And I would argue we never have. We've used those robotic senses, these tools that extend our reach, to touch our larger solar system. But we're pretty close to a point, and there's a lot of energy now where we get to go out now too and explore further. The human body is a remarkable tool for understanding an environment. Harrison Schmitt figured out more things about the moon in the 20 hours he had on the surface over 3 days than everything else that had come before it. Imagine what happens when it's not 3 7-hour sessions, when it's a group of scientists over a month exploring the moon. What will we know then? I can't wait to see what happens next. Thank you so much for your time.